Hi, Algebra Tours. It's day 7 of our transformations unit, and it's problem solving, which you know what that means. It means word problems. So we're going to do some of these together. We'll save some for class, but the biggest thing with these is just make sure as you're reading through that you understand like what are X and Y or whatever variables that are being thrown at you, what are they representing? Because otherwise you can't really understand what the question is if you don't get that piece of it. All right. So this very first one, I like this one. It says an arch is to be constructed so that its shape follows the curve of y equals negative 1/2 x squared plus 10x, where x measures the horizontal distance. So down here is the horizontal distance along the ground. And then the y measures the vertical height. So that kind of makes sense. You're literally looking at it as how much space does it take up here, and then how tall is it? Right? Both in units of feet. Awesome. The general graph of the arch is shown below, which makes sense because it's a negative x squared, so an upside down parabola should make sense. Based on the equation, what is the height of the arch at the turning point or at the vertex? Right, that's what we're talking about there. So what is the height? So keep in mind, we said x is the horizontal distance. Y is the vertical height. So when it's asking for the height, you're asked for a y value here. What I would suggest is letting the calculator do the work. To calculate that top point, that is the maximum point of the graph. So what we can do is we can do second and then trace and then max. Now, way back in the very first unit, there was a reference sheet attached to your note packet. So if you still have that note packet, it's on there. So if you need a little reference to remember how to run these things, feel free to go look that up. Otherwise, into your calculator, because you better have your calculator nearby, go ahead and type in negative 1/2 x squared and then plus 10x. Now, if you graph it, most likely you're on a negative 10 to positive 10, negative 10 to positive 10 on the y-axis window, which means you see part of it. We basically see like this little smush right here, but that's all we see. So you're going to need to change your window so that you can see what's going on. It definitely looks like we need to look higher up. We also need to look further over. So into the window. I'm not going to change the minimum value. I actually think it's perfectly fine to see a little negative, but my x max, let's change that and make it bigger. So let's make that like 30. And then my y max, let's go and make that like 70. Right? Now, as for the scaling, that's just up to you if like the tick marks are going to bug you. Otherwise, we change the x max and the y max and then hit graph. Now, if you were doing this on your own, my suggestion would be change one of them, see what you can see, then change the other one. Because if you change too many things at once, sometimes you go in the right direction one way and the wrong direction the other, you kind of confuse yourself. So now that I can see the top of it, let's run those steps. So second, trace, max. Second, trace. Maximum is choice 4 there. It's going to ask you for a left bound, a right bound, and take a guess. So shimmy to the lefts, come on back to the right, and then somewhere in the middle. So notice those two arrows are pointing at each other because you're telling the calculator it's somewhere between there. So when you hit enter, mine, keep in mind, I don't know how well you can see that, but it came up as 10.000003. It really is trying to tell you 10, all right? So the calculator sometimes gives you something a touch funky, but it's trying to tell you that that is the point 10, comma, 50 right there, right? So how do we answer the question? Well, when it's saying what is the height, we said that is specifically the y coordinate. So the height is equal to 50 feet. So that's how high up this graph is going right here. Or the arch, I should say, is going to go. Right? And then it says, if a second arch was to be created at the same height, but only half the width. So I want the height to stay the same, but half the width. Determine an equation for the arch. Same height, half the width. All right, so we are in the transformations unit. I want you thinking about how would you transform this? So if I want half the width, I would have to squish this to be narrower, which means we would be compressing it in the horizontal direction. So this is a horizontal compression And we would say by a factor of 2. But you can see where the half the width part comes in here. So what that means is that f of x, think horizontal means it goes on the inside with the x. And if I want it to go to half, then I would put in the opposite of that. I would go 2x, because on the inside is always the opposite. Sounds a little funky. What the heck does that mean? Let's take the equation and we're going to plug in 2x into the equation that's given above. Right? So the equation given is just y equals, but y and f of x are interchangeable. So if I write it like this was the initial equation that was given to us, and I just put an f of x in place of it, it makes it a little easier because we're used to thinking this in function notation. So now we can create f of 2x. So let's plug in. So in place of the x, put a 2x here. In place of the x, put a 2x there. And now let's clean this thing up. So 2x quantity squared would be 4x squared, but you're going to multiply that by the negative 1/2 out front. This would turn into 20x. So once we clean all of it up, we end up with negative 1/2 times 4 would be negative 2x squared, and then plus 20x. This is going to be the equation. And now we didn't say g of x, f of x, whatever to call it. So I'm just going to make it y. All right. This should be the equation of the arch. That would be half the width. So let's test it out. On your calculator right now, you should have the original equation. So when you have the graph, you can see it. Don't delete it. Go down to y2 and let's put in our new equation. So we came up with negative 2x squared plus 20x. And if we graph it, what we should see is a parabola, or an arch in this case, same height, half the width. Right? How could you convince yourself of that? You could see, like, what's the x-intercept here? Does it come out to be half of that? The height, could you calculate the maximum height here and confirm it? Absolutely. Let me hop over to the graph that I want, and I would have to go left bound and then right bound and take a guess. And it's coming out as 4.99999, but at half the x coordinate, at 5, it's got that same height of 50. So that's a pretty good way to convince yourself right there. So what we ended up with is just this narrower little parabola right there. All right. Perfect. All right. On to the next page. We're actually going to save those ones for practice in class. So numbers 2 and 3, we're going to chat about those guys when I see you next. What I want to do is get into the bulk of what this lesson is about, is some new questions that we haven't looked at yet, not just kind of practice or review. Sorry there, taking a sip of my coffee. All right, starting to start these ones off. The steps are given just to save us some time. So what we're going to do is we're going to read through. We got some more word problems, and it's telling us we're going to start with the parent function. So we know what that is. It's the most basic graph that represents the shape. So if it's an arch shape, then it would be a basic parabola, an x squared. If it's an absolute value shape, like a V shape, then we'd stick with that. All right. And just as a little hint, we're going to see some absolute values going on here. It says, consider any vertical or horizontal shifts and adjust the equation. And then we're going to let A represent a vertical stretch. And now when we say vertical stretch, it really could be a vertical dilation, meaning a stretch or a compression here. So probably think of that more generally as a vertical dilation. And how we'll calculate what A is, we'll plug in a point on the graph, just not the vertex, and solve for A. And then ta-da, plug A back in and you've got it. All right. When we see it, this will make more sense, but just know that those are up there to reference. So this first one says, that light travels in a straight line and can be modeled by a linear function. And then when it's reflected off a mirror, it travels in a straight line in a different direction. So you might have done stuff like this in like your science classes back in the day, even when you were littler. So the angle of incidence, angle of reflection, those terms might be familiar to you, but that's the idea, that that angle stays the same coming in, coming out. So that's how you can start to see like a little V shape. Even though it's sideways, you can see where the absolute value would come in here. So it's saying, for physics, it comes in at the same angles, it's reflected away. So we can use absolute value to model it. There you go. So at a science museum exhibit, it's saying a beam of light originates at a point 10 feet off the floor. It's reflected off a mirror on the floor that's 15 feet from the wall that the light originates from. How high off the floor on the opposite wall does the light hit if the other wall is 8.5 feet from the mirror? Okay, that's a lot of stuff going on. You really need to draw a sketch to understand what is happening with this problem. So to be able to draw a sketch, reread it, underline any important details. So it's saying at the science exhibit, a beam of light originates at a point 10 feet off the floor. Right? It's reflected off a mirror on the floor that is 15 feet from the wall that the light is on. And then how high off the floor on the opposite wall does the light hit if the other wall is 8.5 feet from the mirror? Okay. So what you have to kind of think of is I'm going to use the y-axis as my wall here. Mm-hmm. And then the x-axis, I'm going to use this as the floor. So it's saying that the first light is 10 feet off the floor. So that means 10 feet up here. Here's where the first light is. All right. It says there's a mirror on the floor 15 feet from the wall. So 15 feet from the wall means come over, 15. And here's where the mirror is. Mm-hmm. So the light comes down. It hits the mirror and it bounces back up. And now it says, how high off the floor on the opposite wall does the light hit if the other wall is 8.5 feet from the mirror? So if we go 8.5 feet from 15, 15 plus 8.5 is going to bring us up to 23.5. So keep in mind, my spacing is kind of generic down here, but I'm going to say over here at 23.5, there's going to be the other wall. Right? So maybe it comes up something like this because it's not quite the same distance away. And that is not supposed to be curved. That is supposed to look like two very nice straight lines. So sorry if it looks a touch funky. All right. So when it's saying how high off the floor does it hit, that means it's asking you for the height. So what we want to do is we want to find the height or the y value when the x value is here at 23.5. That is ultimately what this question's asking. So there's a lot to kind of set up here, right? So let's follow the steps. The first thing is what we should be seeing is that V shape stand out. So the parent function for an absolute value is just y equals plain old absolute value of x, all right? The second thing, consider any vertical or horizontal shifts. Well, this one would have a vertex at 0, 0. That is not where the vertex is here. That's 0, 0. So I need to shift from 0, 0 to the right to the point 15, 0. So to get it to shift right, think about what you know. You would have to, on the inside with x, subtract 15 to get it to go to the right 15. Mm-hmm. Next thing, let A represent a possible vertical dilation. That means it has to go in front. So a vertical dilation means I'm going to put an A in front of there. And then what we want to do from here is we want to figure out what that possible vertical stretch is, right? By plugging in a point that is not the vertex. So I can't use this point. But if you look at the graph, do we know any other points that we know are on the graph right here? We're looking for this, but we know that guy. So the coordinates of that point right there, that's the point 0, 10. Right? So we can use the point 0, 10, and we can plug in for x and y, because here's my x, there's my y. Right? So I'm going to slide my paper up because I realize I'm about to not be seen here. So let's actually try it. So in for the left goes 10. Keep the a, that's what we're trying to solve for. In for the x goes the 0. And now we're going to solve. All right, so 0 minus 15, that would be negative 15. but the absolute value of negative 15 is 15. So I'd have 15a here. So I'm going to put the 15 in front. And then last thing, divide to solve for a. So 10/15, that's the same as 2/3. So based on that, the ta-da, we've done it, is we can plug in and say that 2/3 and then x minus 15 is the equation of this absolute value graph that we sketched here. Now, if I want to be certain, can I go to my calculator and confirm? Yep. So I'm going to try. I'm going to type in 2/3 and then go to math to get my absolute value symbols here, x minus 15. Now, how do I check this? If I go to the table of values, see if those points are on there. So there's 0, 10. I should also have the point 15, 0. There it is right there. All right, so that's a good sign right there. But what we were looking at is basically that 2/3 is sort of the slant of the line or the slope of it. So 2/3 this way, and then that would be a negative 2/3 in that case, but you get the gist, all right? So you can't assume that it's a perfect basic slope of just 1 and -1 for an absolute value. We have to consider, has it been stretched out? Has it been compressed? So that's how we look at it. Or I should say, sorry, vertically stretched out or compressed, not this way. All right, so the last part, let's answer the question. What is the height when x equals 23.5? So let's plug in x equals 23.5 and solve. So we've got our 2/3 and then 23.5 minus 15. 23.5 minus 15 is actually going to bring us right back to that 8.5. And then, whoops, we can calculate that. Go back to that home screen. So 2/3 and then times the absolute value of 8.5 is just 8.5. And so I end up with 5.6 repeating, which is the same as 5 and 2/3. But because it's feet, you could also think, what's 2/3 of a foot? That would be 5 feet and then 8 inches. So a lot of ways to answer this question. I don't really care which, it didn't specify, but it did not say to round. So I would probably say something along the lines of this, where I'm not rounding that answer there. So that's the first one. So let's try one more of those so that you get a better feel for, all right, I've set it up, I've seen it. Let's try it again from start to finish. So the last question of the day says, suppose a musical piece calls for the orchestra to start in fortissimo, about 90 decibels, decrease steadily in loudness to pianissimo, about 50 decibels in 4 measures, and then increase steadily back to fortissimo. Right? I am not a musical person, but I can follow the basics here. So it says, describe what the graph of this function would look like. Right? Well, if it's starting at a certain volume, it decreases, and then it comes back up. You can kind of see that this is going to look like an absolute value. All right, so that's kind of cool. We're going to stick with what we know. So let's actually sketch it a little bit more accurately, though, so that we can write the function. So let's see, the two things that we're talking about here. It's talking about the speed, or not the speed, sorry, the loudness of the sound, and then the number of measures that it takes. So the measures, that's your time, essentially. Time's always your x value, your independent variable, right? The loudness is going to depend on how much time has passed. So the loudness, or the sound, I should call it, I guess, is going to be our y variable, all right? So when we set this up over here, x, that is going to be our number of measures. Okay. And then over here, the sound, or the loudness, however you want to think of it, some sort of thing. That's going to be our S. And now the reason I use S and using M here is because it says use the sound level S to represent that, and use the number of measures M over here. So can you still label it X and Y? Yep, of course you can. Okay. So it says at the start of the piece. So at the start, so at 0, it's starting up at 90. It decreases steadily, so meaning that a steady slope, all right, to pianissimo, 50 decibels. So let's say like 50s here, all right, after 4 measures. So if we come out to 4 measures, wherever you want to make that, it's going to be here. And then it increases steadily back to fortissimo in another 4 measures. So we'd be up to 8 measures at that point, and we're back to 90. So it's going to look like that. And then back up to this. Right? From here, let's write the function. So if x and y makes it easier, let's use that, and then we can plug back in with the s and the m piece of it at the end. All right. So we're looking at y equals absolute value of x, or I can simultaneously, just for this moment, oops, making stuff up here. Got my handy little white out. I'm going to fix that. Equals the absolute value of m. Right? So we're starting with this. Step 2, let me bring back our directions from the other page. Step 2 says consider any vertical or horizontal shifts. Okay, well, the vertex, again, would be for the basic at 0, 0. Take a look at 0, 0. The vertex is not here, it's over here. So we need to shift it to the right 4 and up 50. So to get it to move to the right 4 and up 50, think about how you want to adjust this. Right or left goes on the inside with x, so that would be subtracting 4 on the inside. Up 50, that goes on the outside, so that's plus 50 out here, right? Next thing, step 3, consider a vertical stretch. Now here's where I don't have to do a times the whole thing. We can just put a in front of this, and you're actually okay, all right? So we're going to take a point that we know is not on the graph, that is not the vertex. Because if we use the vertex, it would actually just cancel everything out. You'd very quickly realize it wouldn't help you at all. So we know 2 points. We know the point 0, 90, and we know the point 8, 90. So you can use either one of those, right? So maybe we use the point 0, 90, and we're going to plug in. So here's my x, here's my y. So 90 goes in on the left, keep the a. 0 or, oops, I just realized I copied that wrong. Good thing I got whiteout sitting next to me today. In case you were yelling at the screen like, you wrote the wrong thing. Yeah, sorry. All right. 0 or 8 is what you could plug in for the x here. And then either way, what you'll notice is that you get a difference of either 4 or negative 4. And when I take the absolute value of that, I would get 4a. All right, let's keep going. So subtract 50. We end up with 40 equals 4a. Divide by 4, a comes out to be 10. So the slant of the line, or the slope of the line, is 10 here, and that would be negative 10 there. Now what we're going to just do is plug that back in. So I can plug it back in with my x and y. So it looks like this. Or we can finish it off by saying the sound is equal to 10, and then times the absolute value of m minus 4, and then plus 50 here. All right. That's the first thing. The last part asks you now to use it. After how many measures should the orchestra be at the loudness of mezzo forte, or about 20 decibels? Right? So they're asking you for after how many measures. So what x value has the loudness or the y value at 70? Or I can say find the m value when the s value is 70. However you want to think of it. So let's try to stick with the variables that we're supposed to. Let's go 70 on the left. 10, we'll keep m here. Right? Solving absolute value equations was way back in the very first unit of the year. I say way back, but it wasn't that long ago. So we can get the absolute value alone. So this will give us 20. Because we can nicely get rid of that 10, let's do it. Divide the 10 out. We get 2 over here, and then the absolute value of m minus 4. Now I'm about to run out of space, but I can still make this work. Absolute value equations means you need to split it and create 2 separate equations. You drop the bars, you set it equal to positive 2. You drop the bars and you set it equal to negative 2, because there's 2 possible values inside of here that the absolute value would come out to be positive 2. All right, if I add 4 here, this will give me m equals 6. If I add 4 here, that'll give me m equals 2. And if I look up above, that would make complete sense. So come right back to the graph. At 2, it would make sense that it would be at that middle of 70. At 6, it would make sense it'd be at that middle of 70. So could we have solved it graphically? Yep, that would be another way to have solved it. But algebraically works just as well. All right, guys, that was a little bit of a longer lesson. I hope you stuck it out. Don't forget to answer the post-video question, and we'll chat more about it later.